friends, my name is Amita, and in this video I am going to discuss about one more important topic of in power electronics, that is a steady state analysis of a chopper. My dear friends, in my previous video I have already discussed about the basic concepts of a chopper, the various control strategies of a chopper, operation of a chopper, step up chopper and step down chopper. If you are interested to learn those basic things, kindly see the video links which I have given in the description. In this video, I will be mainly focusing on a steady state analysis of a step down chopper, where we are going to calculate the expression of a current during on time. We are also going to determine the expression of current during off time. Then we are going to calculate the expression of a maximum current and a minimum current, what will be the extinction time, and what is the condition to make the load current continuous. So now, without wasting time, I am sharing my screen where we will do the detailed analytical calculations for the analysis of a chopper. So let us start with a steady state analysis of step down chopper. Okay, so basically when I talk about the steady state analysis of a step down chopper, that means we are going to derive the expression of load current during turn on time. Okay, the second thing, we are going to calculate the expression of current during off time. The third important thing which I am going to calculate, the expression for maximum current, that is load current magnitude. Then how to calculate the expression for minimum current, what is the condition for continuous conduction, okay, and at last we are going to calculate the extinction time. Okay, so one by one we are going to derive the following things. Number one, we are going to calculate the expression of a load current during on time. So if you see the operation of a step down chopper, in a step down chopper, if I draw the equivalent circuit during on time, as the name indicates, step down chopper is a chopper in which our output voltage is less than the input voltage. So that's a very basic thing. Now, if I draw the equivalent circuit of a chopper during on time, so before going to the analysis, let me have a quick review of a step down chopper. Step down chopper is a chopper in which the output DC voltage is less than the DC input voltage. Okay, suppose if the output voltage is V0 and input voltage is Vs, then V0 will be less than Vs. If you have remembered the power circuit diagram of a chopper, that was like this. There is a chopper whose symbol is represented by switch in one box, and there is a one freewheeling diode. This is FD. This is chopper plus minus Vs, and here we were having the inductance, and here we were having the load. Okay, this was the equivalent circuit of a chopper. And if you have remembered that to brief its operation, if I talk about its operation, it can operate in two modes. One is called as a conducting mode, another one is called as a freewheeling mode. Conducting mode is the mode which exists for T1 time, and in this mode the chopper is on. When chopper is on, we say it is the conducting mode, and it exists between 0 to T to TON. The second mode was the freewheeling mode, or it is also called as a non-conduction mode. This mode exists from TON to T off It means in this duration, as it is also called as a non-conducting mode, means chopper is off. Okay, so here after this brief review of a step-down chopper, I am going to derive the expression of a current during on time. So first I am going to calculate expression of load current during conduction mode, that is IT. Okay, so during conduction mode, suppose the load is of RLE type, that is a DC motor load. So the equivalent circuit during conduction mode will be, what is the equivalent circuit? Chopper is on, so it will act as a short circuit. Freewheeling diode is open. Here is a Vs voltage. This is chopper, and the load is RL E type. RL E type. So you can see in this case, the current will flow like this, and this current will be IT, and we are interested to determine the current of the expression of this current. Now, if I write the Kbl equation for the given series circuit, okay, what will be the Kbl equation? Vs is equal to RIT plus L dit by dt plus E. This will be the Kbl equation. Now, if I take the Laplace of it, take the Laplace. Suppose this equation is equation number 1. Okay, if I take the Laplace, because my job is to calculate the current, so take the Laplace transform. You know what is the equation? Vs is equal to, so Vs is a constant value. So what will be the Laplace of this? Vs by S is equal to RIT. IT का लाप्लास क्या होगा? IS. इसको भी मैं कैपिटल S लिखती हूँ. Okay, so this is capital S is equal to RIS. Then plus LDI by dt का लाप्लास is LS IS minus I0 minus. Differentiation का लाप्लास we calculate like this. And again, E is a constant value because it is a DC source. So E by, okay. Now solve this. E by S, let us take it right hand side, left hand side. So Vs minus E by S and R I S plus L S I S minus L I0 minus. Now what is I0 minus? I0 minus will be the current at the starting of turn on time, and current at the starting of turn off time, that will be the I minimum. Turn on time के start होने पर current क्या है? That is I minimum. Okay, so let's put this value. So what I am going to get? Vs minus E by S, that is equal to RIS plus LSIS minus L I minimum. Now we can take this term here also. So what I am going to get, IS if I take common, I will get LS. Okay. So I will get R plus LS. Just a minute. I will get R plus LS is equal to Vs minus E by S plus I minimum. This is what we were getting. Li minimum. Sorry. Li minimum. Okay. Now, if I want to calculate IS, that is Vs minus E by S R plus LS plus Li minimum R plus LS. Now I can take L common. Vs minus E. If I take L common, then S plus R by L. And here also, if I take L common, it will be S plus R by L. Now L से L cancel. So what finally I am going to get? Vs minus E by L, then 1 upon S plus R by L, then plus I minimum S plus R by L. So let us further write this again equation. So what I am going to get, Is is equal to Vs minus E by L. Now do the partial expansion A by S plus B upon S plus R by L. And here I am going to get I minimum upon S plus R by L. Now to determine the value, because this is the current in S domain, I am interested to determine the current in time domain. So I need to calculate this A and B. So for calculation of partial expansion coefficients A and B. How to calculate A? A we calculate what is the denominator of this, that you have to multiply at numerator, then S plus R by L में you have to put S is equal to 0. So this value will come L by R. Similarly B calculate करने के लिए S plus R by L divide by multiplication of both things and put here S is equal to minus R by L. So you will get minus L by R. Now put the value of A and B in these expressions. So what I am going to get, Is, that is equal to Vs minus E by L. A की वैल्यू आई है L by R into S, B की वैल्यू आई है minus L by R, and then S plus R by L, then plus I minimum S plus R by L. Now here L by R I can take common. So Vs minus E by L into L by R, and in bracket I will get 1 minus S upon 1 plus 1 upon S plus R by L plus I minimum S plus R by L. Now here you can see L से L cancel. So finally I am going to get Vs minus R 1 by S minus 1 upon S plus R by L plus I minimum S plus R by L. Now take the inverse Laplace. Okay. So if I take the inverse Laplace, what I am going to get? 1 by S का inverse Laplace is 1. और इसका inverse Laplace is e की power minus R by L t. And इसका भी inverse Laplace is e की power minus R by L into t. So Is का inverse Laplace will be it. Then Vs minus E by R 1 minus e की power minus R by L into t. Then plus I minimum e की power minus R by L into t. So this is nothing but it is the expression of current during turn on time. इसी को हम बोलते हैं expression of load current during turn on time, TON, or you can say during conduction mode. Agree? So first parameter we have calculated. Let this equation should mark as a 2 number. Okay. Now the second thing we want to calculate, that is expression of current, expression of load current IT dash during turn off time of chopper. Now if I draw the equivalent circuit, suppose the chopper is off for TOF time, then the equivalent circuit will be as follows. So what is the equivalent circuit? Let me draw. Chopper is off means it will act as an open circuit. Freewheeling diode is acting as a short circuit. And again the load is RLE. And this is FD. This is chopper, and here plus minus Vs. Now the current will flow like this. and this is IT dash. Now, if I write the Kbl equation, so what equation I will write? RIT plus LDIT by dt plus E, that is equal to 0. This is equation number 3. Now, take the Laplace transform of equation 3. So what I am going to get? RIS plus LSIS minus LI0 minus plus E by S, that is equal to 0. Now what is I0 minus? For turn of time of chopper, the I0 minus will be equal to I max, that you can see from my previous video. So I0 minus, I can write I max. So if I write these values are IS plus LSIS minus I max L, that is equal to plus E by S, that is equal to 0. Now I can take IS common, so here I will get R plus LS, and here I will take minus ES plus I max L. Now IS is equal to minus E by S R plus LS plus I max L upon R plus LS. Now do the partial expansion. So what I am going to get? Minus E. Before partial expansion, let us take L common. So E by L, S plus R by L plus I max L फिर से कॉमन लेंगे तो R by L plus S. So L से L cancel. So what I am going to get? Minus E by L and 1 upon A by S plus B upon S plus R by L, and here I max S plus R by L. Now once you do this, now I want to, so finally what I got, IS is equal to minus E by L, A upon S, B upon S plus R by L plus I max S plus R by L. Now calculate the partial expansion coefficient. Calculate the partial expansion coefficients A and B. So how to calculate A? Put S upon S plus R by L में what I need to write? S is equal to 0. So this L by R. And B I will calculate S plus R by L में S by S into S plus R by L, put S is equal to minus R by L. So this I am going to get minus L by R. Now put the value of these partial expansion coefficient. So IS is equal to minus E by L, L by R into S, minus L by R, S plus R by L. Then plus I max upon S plus R by L. Now take inverse Laplace. ठीक, ये L by R कॉमन आ जाएगा, तो ये कैंसिल हो जाएगा and R बाहर आ जाएगा. So finally IS is equal to, let me rewrite again. So IS is equal to minus E by R, 1 upon S minus 1 upon S plus R by L plus I max upon S plus R by L. Now inverse Laplace लेंगे तो IT minus IT dash minus E by R 1 minus E की power minus R by L T dash plus I max E की power minus R by L T dash. This is your expression of current during off time. So this is equation number 4. Okay? Now you got two equations. एक equation हमको मिला Vs minus E by R 1 minus E की power minus R by L t plus I minimum e to the power minus r by L into t. Now we know that TOA, that is the time constant of RL circuit, time constant of RL circuit, that I can write it as L by R. So IT I can write it as Vs minus E by R 1 minus E minus T by TOA plus I minimum e to the power minus T by TOA. And IT dash, I can write it as minus E by R 1 minus e to the power minus T dash by TOA plus I max e to the power minus T dash by TOA. So this is during on time and this equation of expression during off time. So I have calculated the first thing, that is the expression of current during on time and expression of current during off time. Now the third thing I am going to calculate I minimum and I maximum. I minimum and I maximum. Okay, so for this, as we know that IT is equal to Vs minus E by R 1 minus e to the power minus T by TOA plus I minimum e to the power minus T by TOA. Okay, we know that at T is equal to TON. When T is equal to TON, then IT will be equal to I max. Okay, so put these conditions in above equation of IT. So IT की वैल्यू क्या है? I max है Vs minus E by R 1 minus e की पावर minus t की जगह क्या लिखेंगे? TON by TO plus I minimum e की पावर minus TON by TOA. ये बाउंड्री कंडीशंस हमने रख दी. ठीक, इसको अगर हम फिर से सॉल्व, इसको अगर सपोज I am saying this is equation number 1. Now again, as we know, during turn of time, the expression of current IT dash that we have calculated minus E by R 1 minus e to the power minus T by TOA then plus I max e to the power minus T by TOA. Now we know that at T is equal to T dash, we know that T dash is equal to T minus TON. Okay, why? Because see, as you know that we will get this kind of output voltage. This is turn on time, this is turn off time. So this is T0, this is TON, this is T. So turn off time का इसमें जो यहाँ से लेके 0 से लेके TON टाइम तक एक्सप्रेशन ऑफ करंट क्या है? IT. और TON से T तक एक्सप्रेशन ऑफ करंट क्या है? IT dash. Means T dash के लिए this point of TON will be 0. Whereas IT के लिए this is 0. ठीक? So T dash will be equal to T minus T dash. जब 0 होगा तो T dash की वैल्यू जब T minus TON होगी, उस केस में IT dash की वैल्यू कितनी होगी? I minimum. जब T dash की वैल्यू इस पॉइंट पर, अगर आपको याद हो, इसका मैंने करंट भी ड्रॉ किया था. The current will be like this. Okay. तो ये I max है, ये I minimum है. तो जब T dash की वैल्यू जब, so please see when T dash is equal to TON. So the next thing is expression for I max and I minimum. So for that we need to put some boundary condition. We know that IT is equal to Vs minus E by R 1 minus e to the power minus T by TOA plus I minimum e to the power minus T by TOA. If you are able to recall the waveforms in a step down chopper, this is Vs, On time mein I will get the load voltage, off time mein I am not going to get the load voltage. So this is on time, this is off time, and this is T. This is the output voltage. And if I want to draw the load current, it will be like this. On time mein current will increase, and off time mein current will reduce. So suppose if this is I minimum and this is I maximum. Now you can see that at t is equal to TON. What is the value of IT? TON matlab this point. What is the value of IT? I max. So I can replace IT by I max. So suppose this is equation number 5. So put these boundary conditions in this equation. So what I am going to get? I max is equal to Vs minus E by R 1 minus e ki power minus T. T ki value what I am supposed to write? TON divide by TOA plus I minimum e ki power minus TON by TOA. Okay. So this is how we will put the boundary condition in the equation of T. Now at the same time, in this duration, the expression of current is IT. Okay. And for this duration, the expression of current is IT dash. Means T dash ke liye 0 will be here. Iska matlab T dash when it is equal to T of, what is the current? I minimum. Ye again fir kya ho gaya? I minimum. So now during off time, what is the current? During off time, we have calculated the expression that is minus E by R 1 minus e ki power minus T dash by TO plus I max e ki power minus T dash by TOA. Now I know that when T dash is equal to T of, and T of I can write T minus TON also. IT dash value will be, what is IT dash value? That is I minimum. That is I minimum. So put these boundary conditions, put the above boundary conditions. Suppose this is equation number 6. So put the above boundary conditions in equation 6. What I am going to get? I minimum, that is equal to minus E by R 1 minus e ki power minus TOF by TOA plus I max e ki power minus TOF by TOA. TOF ko I can write T minus TON. So I can further rewrite this e ki power minus T minus TON by TOA plus I max e ki power minus T minus TON by TOA. Okay. So this is equal to I minimum. Now I already told you that we got the two equations. So if you solve it, you are going to get I max value that is equal to Vs by R 1 minus e ki power minus TON by TOA divide by 1 minus e ki power minus T by TOA minus E by R. And the value of I minimum, I am going to get Vs by R e ki power TON by TOA minus 1 upon e ki power T by TOA minus 1 minus E by R. So this is how we are going to calculate the value of I max and I minimum. Okay, so this is the third and fourth component which you are interested to calculate it. Okay, now the next thing is condition for continuous conduction. So how we are going to determine this, that if you want to derive the condition for continuous conduction, it means the threshold value is when I minimum is equal to 0. That means it will not be in continuous conduction. So put the I minimum value is equal to 0. So what is the I minimum value? Vs by R e ki power TON by TOA minus 1 divide by e ki power T by TOA minus 1 minus e by r, that should be equal to 0. So from here, I am going to get Vs by r e की power tun by qa minus 1 upon e की power t by qa minus 1, that is equal to e by r. So r से r cancel. What I am going to get Vs e की power tun by qa minus 1 e की power t by qa minus 1, that is equal to e. Okay, now cross multiply it. So what I am going to get e की power tun by qa minus 1, okay, that is equal to e by Vs, and here I am going to get e की power t by qa minus 1. Okay, so now, yeah, now what I can do, I want to calculate the condition, I want to determine the condition of an continuous conduction in terms of duty cycle. What is duty cycle? Tun by t. That means I have to solve this expression so that I will get some expression in terms of duty cycle. So what I can do, I can take this one right hand side. So e की power tun by qa, that is equal to e by Vs e की power t by qa minus e by Vs and plus 1. So this is what we are going to get. Now further if I solve it, so what expression I am having? E की power tun by qa, that is equal to e by Vs e की power t by qa minus e by Vs plus 1. Okay, so this is what we are getting. Okay, now e की power tun by qa, that is e की power Vs को, e by Vs को I can write it as m. So I can write m e की power t by qa minus 1 plus 1. Now can I take the log both sides? So if I take the log here, log for the base of e, tun by qa, then log of m e की power t by qa minus 1 and plus 1. Okay, now I want tun by t. So this side and this side I can multiply it by, I can divide by t. So divide by t both sides. So what I am going to get? Your expression is tun by t toa, that is equal to 1 by t log m e की power t by toa minus 1 plus 1. So toa I can keep it here. So tun by t, that is equal to toa by t log m e की power t by toa minus 1 plus 1. And what is this? This is alpha. So alpha is equal to toa by t log m e की power t by toa minus 1 plus 1. So this is the condition for a continuous conduction. Now, one more thing I want to calculate, that is the steady state ripples. That is the steady state ripple. Steady state ripple means what will be the change in the magnitude of current. So you know that the current, load current is going maximum and minimum. So steady state ripple is nothing but Imax minus I minimum. Now what is the formula for Ix? Vs by R 1 minus e की power minus tun by toa divided by 1 minus e की power minus t by toa minus e by r. This is Imax. And what is I minimum? Minus Vs by R e की power tun by toa minus 1 upon e की power t by toa minus 1 and minus and 1 minus this. So it will be plus e by r. So इससे they cancel. So what I am finally getting, Vs by r I can take common. Then Vs by r मैंने common ले लिया. So what I am going to get? 1 minus e की power minus tun by toa divided by 1 minus e की power minus t by toa minus e की power ton by toa minus 1 upon e की power t by toa minus 1. So this is the difference we are getting. Now take the LCM. So what I am going to get? So Vs by R. What will be the LCM? 1 minus e की power minus t by QA and 1 and e की power t by QA minus 1. And here 1 minus e की power minus TUN by QA multiplied by e की power t by QA minus 1. And similarly e की power यहाँ पर क्या मिलेगा? e की power TUN by QA minus 1 multiplied by 1 minus e की power minus t by QA. Okay, and bracket close. So finally, if you solve it, cross multiply it, you are going to get Vs by R 1 minus e की power alpha minus alpha t by QA 1 minus e की power minus 1 minus alpha t by QA divide by, this is QA, divide by 1 minus e की power minus t by QA. So this is the final expression of a I mix minus I minimum. So this is the steady state ripple. If somebody is asking per unit steady state ripple, if somebody is asking per unit steady state ripple, so how to calculate per unit steady state ripple? Per unit steady state ripple that you are going to calculate, that is I max minus I minimum divide by Vs by R. So what I am going to get? 1 minus e की power minus alpha into t by QA 1 minus c minus 1 minus alpha t by QA, okay, divide by 1 minus e की power minus t by QA. This is the per unit steady state ripple. Okay, so my dear friends, whatever information I have shared in this video related to an steady state ripple of related to an analysis of a step down chopper, it will be clear to you. We have discussed in detail about how to derive the expression for a current during on time of a chopper, how to derive the expression of current during off time, how to calculate the I minimum and I maximum value, how to determine the steady state ripple in the load current, and how to derive the expression for the condition of an continuous conduction. So my dear friends, if you are interested to learn more about chopper, then keep watching my videos related to power electronics. Thank you very much. Goodbye.